Hi everyone. Today we discuss about one GATE question from GATE 2020. That is question number 16. In the following reaction, this is the one substrate. We are using two equivalent of sodium hydride and two equivalent of methyl hydride, and we got one product P. So and the number of peaks exhibited by the major product P in its broadband proton decoupled 13C spectra is. So in the meaning of the broadband proton decoupled spectra is basically that we all know that the carbon is attached normally with hydrogen. So 13C is also NMR active and 1 is also NMR active, right? So there is a possibility of coupling. But in this particular experiment, that coupling will not occur. Only 13C will show only one peak. And the number of peaks here basically means how many different types of carbon is there in the particular product. So let's start with some basics. Let's take the methane. How many carbon is there? Only one carbon. So how many peak will get in 13? See, only one peak. In the case of CH3, CH3, how many carbon is there? Two carbon, but we will get one peak because here is a one sigma plane or C2 axis. Due to that, we will get only one peak because these two CH3 are chemically and magnetically equivalent. In the case of CH3, CH2, CH3, there is three carbon, but we will get only two peaks because again one sigma plane or C2 axis, and this that's why these two CH3 are chemically and magnetically equivalent, and this CH2 will show another peak. That's why we'll get two peaks. And in the case of benzene, we will get only one peak because there is a suppose let's say one sigma plane is there. Due to that, these two carbon and these two carbon and these two carbon are basically they become equivalent. And if we take one C6 axis like this, if we rotate this, if we rotate this molecule, if we rotate this molecule, we will get that there is one C6 axis. Due to that also these six carbon are basically equivalent. That's why we also get only one peak. Now let's discuss about one simple reaction. We all know that if there is one carbonyl group here and that is attached with the one C active with CH3 or any active hydrogen group, that hydrogen will be acidic. So here we are using irreversible base sodium hydride and methyl iodide. So here the first will be the proton extraction followed by one SN2 reaction will be happen here. So this sodium hydride means Na plus H minus. So this H minus will abstract this proton and here one carbon and will form. This carbon and can be stabilized with this carbonyl group. So there is a possibility of two attack is possible. One is C attack, another is O attack. Here C attack will be favorable because methyl iodide is soft in nature and here carbon is also soft in nature. Whereas this oxygen center is hard in nature. So we know that soft interaction is good. That's why we will get C attack. Now come to the question. This is our substrate. We are using two equivalent sodium hydride and two equivalent of methyl iodide. So in this case, here in this side, no hydrogen is there, right? In this side, but here is two hydrogen, right? Here is two hydrogen is there, but here no hydrogen, right? So these two hydrogen will substituted by the methyl group. So we'll get this product. And now our next job will be that is there any symmetry? Yes, there is one symmetry, plane of symmetry that is passing through these two bridgehead position, right? So due to this, these two methyl group will be equivalent. These two methylene group will be equivalent. Similarly, these two methylene group will be equivalent. So how many peak will get in the 13C? So 1, 2, 3, this quaternary 4, this methyl 5, this 6, this is 7, this is 8. So total we will get 8 peaks. So here the answer will be 8, right? So for more information, you people can see this video. Thank you.